Good evening. My name is Rita. So tonight we'll be talking on SDLC versus STLC. Like I said earlier, so if we have enough time, we'll conclude with the SDLC. Otherwise, we just do SDLC only. So these are some of the topics, as you can see. What is SDLC? What is STLC? SDLC versus STLC. So SDLC acronym is SDLC acronym of Software Development Lifecycle. It is also called a software development process. SDLC is a framework defining tasks performed at each step in the software development process. I don't know if you guys have come across the word SDLC before. So it's part of software testing. This is essentially what you as a tester must practice. Is the process to which testers are being used or carry out to kind of guide them and then be able to deliver. So we start with what is software development lifecycle? The software development lifecycle, SDLC, is the cost-effective, time-efficient process that development team use to design and build high-quality software. The goal of SDLC is to minimize project risk through forward planning so that software meets customer expectation during production and beyond. So SDLC is, like as I said earlier, is a process that as a tester you must follow. The software development lifecycle is a structured process used by the software development team to design, develop, test, and deploy software applications. And it consists of multiple phases, each with its own set of activities and deliverable. So for tonight, I could say, let's illustrate the SDLC phase using an analogy with the human life cycle. As we progress further, we use that illustration and any other illustration just to make you guys get a deep understanding of what I'm talking about. So for the last line, it says, this methodology outlines a series of steps that divide the software development process into tasks you can assign, complete, and measure. So there's a diagram, a picture here, which shows the egg. This is the forming stage. And then from egg, 3 weeks later, it becomes a chick. From chick, 3 months later, it becomes an adult. Augusta, is there any reason why you're raising up your hand?
Please, can you slow down a little bit, please?
Oh my God. I'm so sorry. I get that a lot. I talk fast. Okay, I'll try. Some people might find it boring as well. That's also another thing, but I'll try. So, okay, yeah. So in SDLC, like as I said, is a process. You have to go from one step to the other, from one step to the other. So, okay, let's use this as an example. Stages of software development cycle. So we have the planning and analysis. We have the define requirement. We have the design. We have the development. We have the testing, deployment, as well as maintenance. Please, if you can take down any of these, I want to believe you guys are with your pen and paper. I know that the recording is there, but trust me, when you write, it sticks. And then you can easily pick that up compared to when it's a video, because trust me, you're going to have lots of videos and it's always difficult to kind of watch all of them again. I've been in that situation before, but when you write, it helps you, especially for interview stages and all. So in this stage, like as I said, is in order. you can go from planning to development. So you have to go through planning analysis and then define requirements. So I said earlier that I'm going to use human analogy for a human life cycle. So let's say the planning and analysis is the conception stage. Let's say the define requirement is the infancy, while the design is the childhood. You then have the development as the adolescence, and then the testing phase as the adulthood, then the deployment as midlife, maintenance as old age. With this illustration, you kind of get what I'm trying to say, that there is no way you can run if you don't crawl or walk. So that's exactly how the software development cycle works. It's in process and it has to be followed accordingly. As you progress, you get a deeper understanding, I believe. So this is another illustration. So as you can see, the arrow is going round, which is the circle. So from the planning analysis, you then go to define requirements. From define requirements to design, and then to the development, and then you have the testing, and then you also have the deployment, and then you also have the maintenance. So it has to go like that in circle. That's why it's called software development life cycle. It's a process, it's a continuous thing. You just have to go that way in circle. Each phase of this SDLC serves a specific purpose as well. It contributes to the overall success of the software project. So it's so essential for you to follow this process. So for each of the stages, I'm going to start with planning and analysis, which is the first one. I'm so sorry. Sorry, I hope my background noise is not coming into the recording. So the planning and analysis is the requirement gathering analysis. So I'm just going to read what is on my screen right now before I go into the explaining. The first phase of the SDLC is the project planning stage, where you are gathering business requirements from your clients or stakeholders. So this stage, like as I said, in the human life cycle, the conception, without conception, trust me, there won't even be an infancy in the first stage. So this stage is a very crucial stage. So the phase is when you evaluate the feasibility of creating the product, the revenue, the potential, the cost of production, the needs of the end users, and etc. So this phase is crucial because there's need for the understanding of the need as well as the expectation of the stakeholders. So that shows that, from what I've just said, that tells you how important it is. Like, as I said, the conception stage is so important that without it, nothing can be achieved. That is how this planning and analysis phase is as well. Without this process, without this phase, nothing can be achieved. So for this is where the next stage through here, you move into the define requirement. So this phase is critical for converting the information gathered during the planning and analysis phase into clear requirements for the development team. This process guides the development of several important documents. A software requirement specification, which is SRS, a use case document, and a requirement traceability matrix document. So for this is where you visualize the gathered documents. This is where you sit down, you kind of picture what you have gathered from the planning phase, or what you have gathered, the requirements you have. And then you use the traceability matrix document, which covers the requirements management, the impact analysis, the risk management, and etc., which is the traceability matrix document. You can do a research on that on your own as well, because this document is used in software development and life cycle to test to ensure all requirements are effectively addressed or through the various stages of the SDLC. So it kind of provides a structured way to trace and manage the relationships between different elements of a project and in terms of test cases and the likes. I hope I'm not too fast. Can I get a yes or no, please?
Yes, you are,
Oh
especially
my
with
God.
the flipping of the like with the way you're moving the whole thing. We are not able to
What
write
do
down
you?
some
Okay,
points.
that's fine. So where are you now? Is that the same for everyone?
I was still at the define requirement.
Yes,
You
it's the
went
same for
over.
everyone.
Yeah.
Okay. Sorry, for the purpose of recording, please. So this one, are you okay with the planning and analysis bit? Can I get a yes or no? Are you okay with this phase?
Yes, the second
Okay.
one. That's where we
Okay.
are.
Okay. Do you want me to take it again, or you are writing it down? Is that what you're saying?
If you can just recap, please.
Okay. So like I said earlier, this phase is critical. This is where you visualize what you've gathered, the documents you've gathered, using the traceability matrix document as well. So the traceability document, like as I said, is very important because this helps you because of what it covers, the requirement management, the impact analysis, the risk management. So this helps you, it's like a guide, it's like a manual. It helps you to define your requirements that you've gathered from the stakeholders. And so like as I said, this document is used in a software development lifecycle to test to ensure our requirements are effective and addressed all through the various stages in SDLC. Can I move to the next stage now?
Yes, please.
Thank you. So for design as well, design phase is where you put pen to paper, so to speak. The original plan and vision are elaborated into a software design document, which is SDD. That includes the system design, programming language, templates, platform to use, and application
The original
security.
plan.
Sorry? And application security measures. This is also where you can flowchart how the software responds to user actions. In most cases, this phase will include the development of a prototype model. I want to believe we know what prototype is. So prototype is like when you have a project and you sit down to visualize it, you draw it out, how you've pictured it, how you want it to look like. So you have like well, it's not a sketch, but let me just use that word, something like that. So you draw out how you want everything to be, how you want it to look, you visualize it. So that's what prototype means. So creating a pre-production version of the product can give the team the opportunity to visualize what the product will look like and make changes without having to go through the hassle of rewriting code. So this is overall an architecture structure phase of the software. It's also an effective design in place to ensure that the software is scalable, maintainable, and meets performance requirements. This design also helps guide development activities and ensure that the final product is well organized and easy to maintain. So I'm going to use this illustration now. Let me start with the planning analysis. Say, for instance, you want to make a dress. Let's assume you don't have the fabric. So you go to the designer and then you say, this is what I want. You tell the designer, can you make a dress for me? And then you start by telling the tailor, let me just use that word, or fashion designer, the kind of fabric you want, which is otherwise the material you want for this dress, which is the planning analysis bit. So now the fashion designer will be taking down all what you are saying, or what you want. And then you tell the fashion designer, um, I want zip at the back. I want this at the back, which is the planning analysis bit. This is where I am now. And then you're saying, oh, I want you to put this there. I want it to be long. I want the sleeves to be 3/4, and all those specification, or all the requirements, or what you want. And then the fashion designer then comes on his own and say, okay, you've given me the requirement, and sit down and kind of put down all what the designer feels will be advantage to that clothes. Because say, for instance, you say, oh, I want the trouser to be 3/4, because if it's 3/4, it will be nicer. And the fashion designer will say, oh, you know what? I don't think if you do it 3/4, it will fit properly, because you want you want it this way, or because you want it high-waisted. So because of that, if it's too long, it might not be nice. So it has to be 3/4, and all those uh, uh, uh um 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 what is it called now, requirement. So that's the defined requirement. Is everyone understanding where I'm going now? Can I get a yes, please, if it's clear?
Yes, please.
Okay, thank you. I hope everyone is following along. And then this bit is where the fashion designer will then sit down and visualize what you've just, all the requirements you have given. This is where the fashion designer can then sit down and make a sketch of what she thinks is what you want. Because don't forget, there's no picture. So now the fashion designer has taken all the information you've given to her and say, okay, from my own point of view, this is what I think you want. And then he draws it out. It makes a sketch for you and then show it to you, which takes us to the next phase, which is the development. The actual development phase is where the development team members divide the project into software modules and turn the software requirements into code that makes the product. The SDLC phase can take quite a lot of time, and specialized development tools. It's important to have a set timeline and milestone so the software developers understand the expectations and you can keep track of the progress in this stage. So basically, in this development phase, the phase is where the software is built according to the design specifications. Like as I said, this is now where the fashion designer starts to make the dress. So it requires quality code and essential for creating a release and functional software product. Because this development stage, this is where it's very crucial. Because if the fashion designer makes the clothes and it doesn't fit well, or it doesn't meet the required specification from the customer, the, the customer will not be happy. So this phase is very important. Proper development practice such as coding standard, version control, and code review has to be in place in software when you are developing. All these things has to be in place for efficient robust software, and easy to expand or modify in the future. So in some cases, the development stage can also merge with the testing stage, where certain tests are run to ensure there are no critical bugs. So this is where you carry out your testing or before. So which brings us to testing. Before getting the software product out the door to the production environment, it is important to have your quality assurance team perform validation testing to make sure it is functioning properly and does what it's meant to do. This testing process can also help hash out any major user experience issues and security issues. In some cases, software testing can be done in a simulated environment. Other simpler tests can also be automated. The type of testing to do in this phase is performance testing, functional testing, security testing, unit testing, usability, and all the rest. So in this is where after I'll go back to the tailor now, the fashion designer. After making the dress, then the customer comes and fits in the dress. And then the customer could then say, oh, you know what? There's supposed to be a zip on this side, or is not tight enough, or is not long enough, or is too short. So this is just the phases of testing. So in this testing phase, that's where you carry out all the necessary testing that is required. Testing verifies that the software functions correctly and meets quality standard, because thorough testing helps identify and fix defects early. That's the truth. And in the development process, it also helps to reduce risk during production, because while we are producing, we are testing. And it ensures that the software behaves as expected under various conditions and provide a positive user experience. That's for the testing bit. So we move to the next phase, which is the deployment. During the deployment phase, your final product is delivered to your intended user. You can automate this process and schedule your deployment depending on the type. For example, if you're only deploying a feature update, you can do so with a small number of users, canary release. If you are creating brand new software, you can learn more about different stages of the software release lifecycle, which is SRLC. So it involves the releasing of the software to the users, which is this deployment. This is to say, oh, we are done, and then you deploy it to the users. Proper deployment practices ensures a smooth transition as well from development to production environment. And then, to be honest, this phase also helps to minimize downtime and disruption for users, and it also allowed them to access the software quickly and efficiently. That is for the deployment phase, which brings us to the last phase, the maintenance phase. The maintenance phase is the final stage of the SDLC. If you are following the waterfall structure of the software development process, which is one of the methodologies, waterfall. However, the industry is moving towards a more agile software development, which is another methodology. So the industry is moving towards a more agile software development approach, where maintenance is only a stage for further improvement. In the maintenance stage, users may find bugs and errors that were missed in the earlier testing phase. This box needs to be fixed for better user experience and retention. So in this phase, if we want to talk about the fashion designer life cycle, after the dress is done and is given to the customer, you want to maintain the zip, you know, you want to maintain how it's been worn or during the washing and things like that. I think that is where this maintenance falls in terms of that illustration. But in terms of software, regular maintenance in software ensures stability. It also remains secure and function over time. So it addresses issues as well as they arise and incorporates user feedback as well and adapts to changing requirements for technology. It depends, as the case may be. So that's it for that. And then we move learning objectives, software development lifecycle, and then different models of SDLC. We also have the pros and cons, concepts. I'm just going to move my Zoom. Let's see. Concepts in understanding testing. So before I move on to this bit, do we understand what I've just gone through on the SDLC? If not, you can just ask one or two. I can see some messages on the chat. I'll quickly check. Other than that, you can raise up your hand if you have anything that you want to ask or say, then before we move.
Sorry, if I may ask. Okay, sorry.
Okay, so sorry, Damilola, hold on 1 minute. Somebody said it's too slow. Okay, if you want to unmute and speak, I'm just trying to make sure that nobody's left out. So because someone said I'm too fast. Yeah. So I'm just trying to, I'm sorry if you, that was why I said earlier, I hope someone else don't get offended by it, because then I try not to be normal because I'm trying to be slow. I do speak fast, so I get that all the time. So that's why I'm asking this question now, in case anyone has been lost, or so that we can just have a quick recap and all that. Thompson, sorry, you can speak now.
Good evening.
Good evening.
So when you're explaining, there's this particular place we talked about. I think that was design phase where we are to write out our plan, and some of the plans are it involves programming and the codes and the likes. So I wanted to ask, are we? I think that should be the work of software developers, or are we going to do a little bit of it too?
Yes. So what we are doing now, you guys have only just started. This is the manual. Bear in mind, you can also work as a manual tester, and then with more money, automation. I think we've done that in the past. I think Mrs. Ayola also did that last week with you guys. The average salary. So we do start with manual so that you can get a deeper understanding before we move into automation. To be honest, when you understand manual, I cannot emphasize on this enough, it helps you to understand automation. So you are going to be writing codes, but when we say codes, they are English. So they are not something like that you don't know what it is. Yeah.
Okay.
So it's English, and then you are going to be taught. You're going to have the framework. You will do everything yourself from scratch, and it's going to be a process. So you guys will start with creating your own frameworks from the scratch, which is Java. And then from there, then you guys will be taught how to write the code. So it will get easier, to be honest, as long as you follow suit. And then once you you don't understand anything, always go back, refer to the videos, and you will always and if it doesn't work out, always put something on the QA grid, and one of your mentors will definitely be there to help you. And this is another opportunity for me to tell you guys, use your mentors. So, well, we haven't really gone into, because we have not even done how to write test cases, even in manual now. So by the time we start all that, you guys will get hold of it. So this is just to make you guys understand what you as a software tester is expected of, why you are being paid this big money. You understand? So that's just what we are doing before we start teaching you how to write or design your test cases, and then from there how to do automation as a software tester. So just picturize yourself they are calling you Thompson QA automation engineer, or Thompson the these are the lovely name, trust me. So you want to get that attached to your name. All right, thank you so much. I hope that's clear anyway, Thompson.
Yes, thank you. I think I get it now.
Yeah. You can do a bit of research on your own as well. It do help, to be honest. It kind of sets you apart. Yeah. Damilola, quickly, please.
Are you saying?
Hi, sorry.
Can I go ahead?
Who is Damilola? Damilola, I can see your
Damilola
hand.
speaking, please. Can I go ahead? I heard somebody talking. That's why I kept quiet.
Yeah, I don't know who that is. Sorry. Yeah.
Okay. Yeah. I was about to ask the question, saying, are we going to major on the old style? And then you answer the question saying, no, we're not likely majoring on the old style. We'll be using agile method. And conversely, you now mentioned that manual testing. So from what you explained, I was not thinking, is manual testing going to be following the SDLC style, or what are you trying to explain?
Yes.
My question.
Like as I said, with manual testing, you have to, it is a process. You have to know manual to know automation. Let me put it that way. So, and the difference is that with manual, you are doing it manually, as the name says, and then you're writing your test cases in Azure. We use Azure here. Old companies uses what's it called? Excel, which I think is only few companies that will still be using that. So most people have moved into using Azure as well as Jira or Confluence. So yeah, that's not the old method. That's waterfall is entirely different from manual or whatever. So yeah, that's a different methodology that can be implemented in any company. So some companies still use waterfall, but we'll get there as we progress. Why some companies still use Agile. Okay, one more question so that we can.
My question is actually, if somebody get a job as a manual tester today, is what is it? Is the person will be followed or be expected to use agile method or SDLC like the old method, which is a long process actually?
Yeah, so each company has what they use. So until you work in an organization, you can know. And sometimes projects, it varies. So some companies still practice waterfall, like as I said earlier, while some companies have moved on to Agile. So waterfall is the traditional way. Some companies still use that. Is
Okay,
that
that
clear?
means, sorry to cut in. That means in waterfall you can do manual, in agile you can do manual.
Yes, yes.
Okay, you get the answer. Thank you.
That's all right. Because this session is being recorded and questions are coming between, I don't know how it will look like for you guys.
The mistake we should have paused the recording when we ask the question.
Yeah, but sometimes some people say they want the questions there. Let me just pause it.
Okay, I'll be your police.
I just want everybody to. Where is my recording now? So we have learning objectives, which is software development lifecycle, different models of SDLC, pros and cons, concepts in understanding, testing. So software development lifecycle is iterative and incremental development models. So basically, we have different types of methodologies, which are waterfall, view model, think spiral as well, and agile. So so those are the types of methodologies, and which are the three major ones are the waterfall, V model, and agile, which is what we'll be talking about today. So waterfall is the linear model, while V model is the sequential development model. Waterfall is also sequential in nature. Then you also have the iterative incremental development model, which is the agile. So for waterfall, this model arranges all the phases sequentially, with each new phase depending on the outcome of the previous one. It provides structure to project management, but there's little room for changes once a phase is complete. So it's best for small, well-defined projects. I think it varies. Why some people think waterfall model is good for big projects that want to last for 2 or more years. Yeah. So you have the requirement phase, you have the design phase, you have the development phase, you have the testing phase, you have the deployment, and then you have the maintenance. So before understanding the basic history of the software testing, before software testing, what is the process before testing? So in this process with SDLC, I must say, is the process. I know I've been using Fabric, but if you don't get because that might applies to mostly ladies because we are the one that makes clothes. Well, another example I can use in the SDLC is like if you are to make something like a medicine, for instance, what happens is you have your requirement, raw material, which then gets developed into a medicine, either tablet or syrup. So which is the proper fit. So just like what I said earlier in SDLC, you have to move from one stage to the other, which is the same in this waterfall model. So the waterfall is a traditional sequential approach where testing is carried out in a linear sequence. This waterfall has multiple phases and are sequential in nature. This requirement phase cannot, okay, what I'm gonna use this, okay, in the requirement phase, for instance, as you can see the arrow pointing down in this picture on my right, I think. The requirements must take place before the design, before the development, before the testing, before the deployment, before the maintenance. Why? Because in waterfall, you cannot start from development, or you cannot finish requirement and then move into development, because what happens is the output of the requirement is what you need in the input of this design. So what you get from requirement is what goes into the design, which is the input. So for instance, let me just start now, say requirement analysis is a setting document that you collect all requirements, which is what I've explained earlier, but I'm just going to explain it briefly, from the customer, which happens to be the output of the requirement analysis, which becomes the input, like as I said, to the design phase, which goes into the design phase. And then each phase must have a clear documentation, because each phase output is the input for the next input. I cannot emphasize on that enough. Each phase output. That's one simple way of explaining waterfall model. So it has to be clear. The requirement phase has to be very clear for it to go into the design phase. Because until one phase is also completed, the next phase cannot be completed. And then which brings us to the pros. Phases are processed and completed one at a time. Works well for smaller projects where requirements are all understood. Then the cons is you complete a stage before moving to the next. If something is wrong in the later stage, there's no chance to going back. This is an expensive model. Yes. So everyone knows that waterfall, which is the old model or the traditional one, is cost effective. And because it's a dependency model, it makes it difficult. It's very challenging for companies to adapt this model. So, because if the requirement phase, say for instance, you have these 6 phases, and you have 10 workers working in each of these phases. This is one of the disadvantages of waterfall model. And the project was meant to last for 10 months. Then the required phase team, while they are working, the remaining phases, the design, the development phase, the testing phase, the deployment, and the maintenance phase, we have to hold on. That means they are not doing anything and they will be paid, which is expensive for the company. Can you see one of the disadvantages now? So if it takes the requirement phase a whole month for them to finish and complete their requirement phase, it's a loss. That's the cost effective. Another disadvantage is by the time you get to the testing phase, let's say for instance, and then the requirement changes. The customer then comes up with a different requirement to say they want to add or take away something from the requirement that has been given in the initial stage. It will affect all these processes, because then your code will have to change. And for your code to change, it will affect the development phase. For that, it will also affect the design. And then, so you see, everything that has been done will look like a waste, because then you have to go back and you have to like start again from the beginning. I don't know I hope I'm not too fast again, if that is clear enough. So, which brings us to the V model sequential development model. Also known as the verification and validation model. The V model guides where testing needs to begin as early as possible in the SDLC lifecycle. Testing is not only an execution-based activity, it also involves various activities that must be covered before the end of the coding phase. V model corresponds to both testing activities and development activities. As you can see, you have the verification phase and the validation phase. So if you look at the diagram on my right, that's the V model. So the difference between them is in vModel, when you gather your requirement, you have to test it. So this type of methodology is an extension of waterfall model, because in this stage, testing activities are aligned with each stage of the development life cycle. So for every development stage, there's a corresponding testing stage, forming a V shape in the name, as you can see. So for vModel, anytime you have a requirement gathering, before you proceed to system analysis, it has to be tested, which is the acceptance testing. For the system analysis, they have to carry out a system testing. So when there's also a software design, they have to do integration testing. And when there's a module design, a unit testing has to take place. So this verification phase, we can say, is for the developer. While they are doing that, you as a tester, you have to be working alongside. So once there's a requirement gathering, you will have to test it to see if everything that has been gathered, if the requirement is exactly what is expected, is exactly if anything has been missed or things like that. So when there's also a system analysis, they have to carry out a system testing. And wherever there's also a software design, integration testing needs to take place. So I'll quickly look at this other picture on my left, which is verification phase and validation phase. Business/user requirement. Detailed requirements of the software system to be developed are gathered from client. So once it's gathered, it's involved testing the product in user environment. And then the software application design. How will the system work and interact, functionality or features that goes into the system? So that's when they now do the system testing. You check the entire system functionality and the communication of the system under development with external system. You also then have the architectural high-level design of the software, high-level technical details of the project, the coexistence of the components that make up the system and all that. That is where integration testing, and then the module detailed design, which goes with unit testing. So that is how vModel is, which is the second methodology. Please, let's not forget the three major methodology: waterfall, vModel, and thirdly is agile, which is the one that is presently being used or mostly acceptable in most companies. Then vModel sequential development model. What is verification? Verification involves evaluating a work product component or system to determine if it meets the development requirement set. The main focus is the deliverable product built according to the specification and standards. What is validation? Validation is a process concerned with evaluating a work product component or system to determine if it meets the user requirement and needs. The main focus here is the deliverable product fulfill its purpose and provide a solution to the customer's problem. Now that we understand the importance of this testing process, let's learn about one of the software models that helps improve the cost and time efficiency, enhances coordination between a team through defining proper roles for employees, and minimize the risk potential when deploying the project. So we also have the pros and the cons for vModel. So testing early in the life cycle, thereby enhancing the probability of building an error-free and good quality product. Yeah, with vModel, to be honest, error will be less because you are testing each phase as it goes along. But the major thing on it, which is the con, is it draws back any changes happen in the midway, then test document along with requirement document must be updated. That's for view model. So, which brings us to Agile, iterative and incremental development model, Agile. With this model, the team begins development with a small set of requirements and iteratively enhances versions until the software is ready for production. It's easy to manage risks, but repeated cycles could lead to scope change and underestimation of resources. This model is best for projects that require high flexibility in their requirements and have the resources to handle multiple iterations. So for Agile consists of Scrum or Kanban. It promotes iterative and incremental development. So testing is integrated throughout the development process with continuous feedback and collaboration. That is between the developers and the testers. In Blue Sky here, we practice Agile, which is, I think is easier if you ask me, because with Agile, you have the individuals and interaction. In Agile development, self-organization and motivation are important as interactions are co-locations and peer programming. Yes, with Agile, you can do peer programming. And you also have working software. Demo working software is considered the best means of communication. What that means is okay, say before I go there, let me say, with Agile, the entire release are divided into different phases. So what happens is you have the first iterative, you have the second iteration, and then you have the third iteration. I beg your pardon. First iteration, and second iteration, and third iteration. So you integrate all requirements and test, and then the customers can have a look at it. So if it requires any changes, that's in like the first iteration. If it requires any changes, you can then go back and do any changes. So where this demo working software comes in, say for instance, which is what we practice, especially in like the advanced team, because we mostly work on greenfield application. So greenfield application, which refers to the creation of a new software application system without being constrained or any existing code or systems. So that's what a greenfield application is, something that is starting from the scratch. Otherwise, the opposite of greenfield is brownfield, an already existing application. Maybe you are being employed into a company, the project is already ongoing, is referred to as a brownfield application or project. So yeah, so with this one, you can then say to the customer after the first iteration and say, you can come and have a demo, a walkthrough of what we've done, whereby you showcase what have been developed so far in the first iteration. Then you if there's any requirement, any update, you take the feedback back again and implement it into the second iteration. By the time you're coming back again, you've kind of meet the required expectation of what the customer is expecting. And then if there's need for any changes again, you take that on board, you take it back again, and then you come back. So that's the phases that we are talking about in Agile model. So it also helps with customer collaboration, as the requirement cannot be gathered completely in the beginning of the project due to various factors. Continuous customer interaction is very important, and get proper product requirements. And responding to change as well. Agile development is focused on quick responses to change, continuous development. So I hope I'm not too fast, because Agile is so broad. There's more to it than what I've listed here. You can also do your research, like I do say, but it's also a very interesting one because it is what we practice here. So I would say maybe by the time you get into the habit of it, which is what we are already doing, you had your sprint 0 already, you're going into sprint 1. So let's assume now in sprint 1, I don't know, I think I saw that you've been given a task of what you should come back with in your next demo. So maybe for sprint 1, you are meant to even have your test plan. Test plan is an overview of your scope, your deliverables, your objectives, your testing environment, everything. As a tester, you are required to have a test plan. So if I know you guys have not been taught on test plan, you can also do a research on test plan. So it's the first phase of testing as well. As a tester, you should have your test plan, well, and your test strategies. So yeah, we are already practicing Agile because now you've done your sprint 0, you are now in sprint 1. So you've been told what will happen or what you guys are expected of in sprint 1. So that's the process. That's how Agile is. And then by the time you start working on your project, it's the same process. So for instance, maybe you've done the header and you kind of demo it to the customer and they want the logo on the left rather than it being on the right. So things like that, you take it back, you bring it back. And then, yeah, that is mainly how Agile is. So you kind of incorporate all requirement tests, then the customers can come and look at it. Agile model is a software development approach that emphasizes iterative and incremental development collaboration between cross-functional teams, flexibility, and customer feedback. So it kind of contrasts with traditional software development methodology, such as a waterfall model, which follows linear and sequential approach. So some of the key principles of Agile as well is customer collaboration, like I said, and then you also have responding to change over following the plan, like as I said, which is, there's more, but these are the 4 that is listed here. Then we also have the common ones. Sorry, I'm looking for my mouse. Yeah. So iterative and increment development model. So this is basically what is expected of you in Agile. The definition of ready and the definition of done. Those 2 things, you must know it, when to start and when to stop. When you say you are done, you are done. And then you start with the backlog into sprint. So sprint then consists of the integration, the testing, the development, and then you deliver, and then you're done. So most common Agile methodologies comes in various forms anyway. And then Scrum development team, which is the sprint planning, like as I say. So in sprint, you have the sprint planning, which is the main Agile, which is where you have sprint 1, sprint 2, and all that. You have your sprint planning, as well as the development team. That is where you then have the developer. You work with the developer, you work with your Scrum Master, and the BAs as well, the business analysts. And then in sprint, you also do sprint retrospective, and then you also do sprint review at the end of each sprint. So you also do daily stand-ups in sprint. So this particular approach is called Scrum. This is the Scrum, whereby you go through the process of sprints, which consists of sprint planning, daily stand-up, sprint review, sprint retrospective, and all the likes. So we have the STLC acronym. So what I'm going to do, let me see, what's the time? 10 past. Okay, I might just quickly go through this because I wanted to finish at 9:30 and then take leave 30 minutes for question and answer, but maybe I'll just quickly go through it. Maybe STLC, I'll try not to be too fast anyway. STLC acronym, what is STLC? So like as I said, we have SDLC, we have STLC. What is STLC? Software testing lifecycle. The software testing lifecycle is a sequence of specific actions performed during test process to ensure that the software quality objectives are met. The STLC includes both verification and validation. STLC mostly sits with Agile. That's the truth. So what is the role of a QA in STLC? Even with the most highly skilled team of developers, mistakes can still happen as a result of human nature. We all know this. The role of a software testing lifecycle is to identify any mistakes that have been made and find solutions for them, helping to maintain the quality of every piece of software produced and ensuring that the project requirements are met. So again, that is the end point, project requirements being met, regardless of the approaches you use, either V-model, waterfall, or Agile. As a software tester, that is your main goal. So the STLC phases, we have the requirement analysis. I'm not going to explain that. We all know what that is already. But we also have the test plan. So the test planning is also like what I said in the planning phase of, or this can also come in as where you have your test plan. Test plan, which is the overview of what is expected of you as a tester, because a test plan is good in the sense that if you are being hired as a tester into a company now, and then you moved to another company, maybe for a better money or a higher promotion, if another tester comes in, they should be able to pick up from where you left it. Why? Because there's a test plan. So it's like a guide, it's like a manual that the testers use to follow suit of what has been done and what is expected. So test plan helps guide testers. I'll put it that way. That's the easiest way to explain it. So it consists of your what's it called now? Your testing environment, your objectives, your scopes, and your deliverables, and so on. Then you have your test design, then you have your test environment, you have the test execution, then you have the test cycle closure. So, like as I said, this is the requirement analysis. The first step of the software testing lifecycle in the phase quality assurance team understands the requirement, like what is to be tested. If anything is missing or not understandable, then the quality assurance team meets with the stakeholders to better understand the detailed knowledge of requirement. In this requirement analysis, this is where you argue that, oh, like as I used the Taylor analogy in the first instance, this is where you say, no, how do you want it to be? Is this how you want it to be? Okay, if you want it to be this way, it might not work, because if we put it this way, this is what you will get. And this is what you want to get. So you want to get actual result, not expected result. I hope it's clear. So the activities in requirement analysis: review the software requirement document, which is SRD, and other related documents. Interviewing stakeholders to gather additional information. You see what I was saying? So because as a tester, you should know if a stakeholder is telling you they want something to be in this. We do have dialogue. We tell developers, no, this is how we want it. Or we say, as a tester, I cannot test this because you know. So, but you guys will get there anyway. Identify any ambiguities or inconsistencies in the requirements, identify any missing or incomplete requirements, identify any potential risk. Because if you know that when something like this is being implemented or integrated into a software, this is what the risk, the potential risk, this is what will happen. You know, you have to foresee it, or issues that may impact the testing process. Like as I said, there are some things that cannot be tested. You tell them, this one, I cannot test it. It depends on what it is. But we'll get there. Let's not get ahead of ourselves. Creating a requirement traceability matrix, like what I told you earlier, to map requirements, to test cases. At the end of this stage, the testing team should have a clear understanding of the software requirement and should have identified any potential issues that may impact the testing process. This will help to ensure that the testing process is focused on the most important areas of the software and that the testing team is able to deliver high quality results. Then deliverables of requirement analysis. This document maps and traces requirement proposed by the clients with test cases to ensure that every requirement has an associated set of test cases against its automation feasibility report, if applicable. This report will be produced as a result of analyzing the project, working at what screens have components that can have automation tests. Did you see where automation test is coming in? So again, there are some features that don't require automation tests, that manual can only be carried out. That's just to let you guys know, but you get there anyway. Written against them, the complexity of, and in some cases whereby you've done manual as well, they have to carry out automation tests on it. But that's if the company is into automation, because some companies are still using manual for everything. The complexity of writing the automation test, whether the test case handle large amount of test data, among other factors. You see, because we test data now, automation is easier you rather want to use automation as a tester when it comes to data than doing it manually, to take a lot of time. Then you have the test planning. It's the most efficient phase of software testing lifecycle where all testing plans are defined. In this phase, manager of the testing team calculates the estimated effort and cost for the testing work. The phase gets started once the requirement gathering phase is completed. The activities in test plan are identifying the testing objectives and scope, developing a test strategy, selecting the testing methods and techniques that will be used. You see, developing and selecting the testing methods and techniques that will be used. This is why I said earlier, as a tester, you should have a test strategy or a test plan. So this is when you know what kind of techniques you want to use to test that project or application or software. Then identifying the testing environment and resources needed. Again, then identifying the test cases that will be executed and the test data that will be used. Then estimating the time and cost required for testing. Also, you have to identify the test deliverables and milestones. You also have to assign roles and responsibility to the testing team. And lastly, you must review and approve the test plan. So if you are not the only tester, your test plan must be approved and must be reviewed. That's what it is. So most cases, you have a test manager. So they will be the one to approve your test plan. Because you as a tester, you will go and write your test plan, and then it will be reviewed by your test manager or whoever is, or your QA lead. Excuse me. At the end of this stage, the testing team should have a detailed plan for the testing activities that will be performed, and a clear understanding of the testing objectives, like as I said, scope and deliverables. This will help to ensure that the testing process is well organized and that the testing team is able to deliver again. You see this high quality, that is where you are going. High quality results. That's just it. As a tester, it must be high quality result. Nothing less is expected. You have to deliver as it is, as it should be. So we also have deliverables of test planning. Test plan documents. The ISTQB defines a test plan as test plan is a document describing the scope, approach, resources, and schedules of intended test activities. How many of us know what ISTQB is? If you know it, put it on the chat. Don't use Google. Then test effort estimation document. This document will include the estimations of how long it will take to complete the testing task. So most time, you will have to do estimation. But I think the one we are talking about here is the duration of the whole project. The estimation one is the one you do in sprint planning. And you also have test case development. Test case development phase gets started once the test planning phase is completed. In this phase, testing team notes down the detailed test cases. You know, I said it earlier in the beginning of this class, you must take notes, even as we are in a training. You have to take note because it helps you and it sticks, you writing it down. The fact that you are even writing it down, it stays on, I don't know about, but it helps. That's just what I'm trying to say. So the testing team also prepared the required test data for the testing. So a test data can also be information needed for the testing, in the sense that if you are trying to test, if you are working on a login functionality, for instance, and you need all your data to put in, the name, username, and your password, you have to have your test data to use for the testing. That's what is required of you as a tester. You should have the test data. And when the testing cases are prepared, then they are reviewed by the quality assurance team. Activities in test case development. Identifying the test cases that will be developed and also writing test cases that are clear, concise, and easy to understand. So this process is talking about which we will get there when we are writing test cases. Because you will have your, user acceptance criteria from the BAs, what is expected, and you will then go as a tester and then say for instance, the BA says, as a user, when I log into JD Spot, I want to be able to view the landing page. And then I want to be able to fill up my cards and proceed to the checkout. When you as a tester is writing it out, either manually or on automation, it's called script, test script. In a manual, it's called test case. When you are designing your test case, it has to be clear. That's what they are saying here. Writing test cases that are clear, concise, and easy to understand. Like as I said earlier, somebody else should be able to pick up your test case that you've designed and be able to interpret it without the need calling for you to come and interpret it. Creating test data and test scenarios that will be used in the test cases. Identifying the expected result for each test case. You must end it with the results that as you've carried out the test, there must have been a result. So you should end it, even if you had a defect, have a clear defect report. Reviewing and validating the test cases. Updating requirement traceability metrics, again, is coming in to map requirement to test cases, RTM. At the end of this stage, the testing team should have a set of comprehensive and accurate test cases that provide adequate coverage of the software application. So deliverables of test case development. Test cases. This is a set of action that tests a particular piece of functionality of the software project. Test data. This input is given to a software program during the execution of the test cases. And then test automation scripts. These are scripts created by automation engineers with the idea of them being run frequently to reduce the reliance on manual testing. This was just what I was explaining earlier. So in automation, they are called test scripts. So it kind of helps reduce, like as I said, if you are doing data with manual, it's quite a lot. It depends on how much you have. Well, in terms of automation, it kind of reduces the time that you will spend. Please, if you are not speaking, please mute yourself because this is being recorded. If you are not speaking to me, please be muted. So we also have test environment setup. It's a vital part of the SDLC. Basically, this test environment decides the conditions of which software is tested. This is independent activity and can be started along with test case development in the process. The testing team is not involved. Either the developer or the customer creates the testing environment. Most time, developers create testing environment. In some cases, the customer can. So test environment is where you will then carry out your testing after the software has been developed. Input has been given to you, and the developer has then developed the software, and then you as a tester, you need an environment to test it. That is where this comes in. Activities in environment setup. Analyzing the requirements and preparing the list of required hardware and software to set up the test environment. Setting up the test environment, executing a smooth test on the test environment will validate the readiness and stability of test environment. Deliverables of test environment setup. The test environment is ready for test execution phase, smooth test results. So as we go along, we'll go into different types of testing techniques, and then you get to understand some of them. Some of them, even as a tester, you are not. It depends on the project you are working on. That's when you know the kind of testing that is required, testing technique that is required. So after test execution, after the test case development and test environment setup, test execution phase gets started. In this phase, testing teams start executing test cases based on prepared test case in the earlier steps. So after you've written or you've designed your test case, you then carry out a test execution. So this is where you validate if what is expected. You verify, you validate if it is expected or actual. If the result is expected or actual. So, but what we are looking for is actual. But if you then get expected, that's when you raise it as a defect. So as a tester, this is where we kind of go deeper from ordinary tester or anybody that can test soup. Let me put it that way. So activities in test execution, the test cases and scripts created in the test design stage are run against the software application to identify any defects or issues. Defect logging. Like as I said earlier, when you discover a bug or a defect, you have to have a clear document. So any defects or issues that are found during test execution are logged in a defect tracking system, along with details such as the severity, the priority, and the description of the issue. I think that's where you have your steps to reproduce in manual testing, mostly on Azure board. When you raise a bug, you will have your test to reproduce. Then you will list all what the report of the test, why it failed, what was expected, and all that. And the actual different from the what you got, which is the expected. Then test data preparation. Test data is prepared and loaded into the system for test execution. Then test environment setup. The necessary hardware, software, and network configuration are set up for test execution. Then the test execution, the test cases and the scripts are run, and the results are collected and analyzed. So when you carry out an execution, they are being analyzed. So you have to make sure it's being done thoroughly. Then the test result analysis, the result of the test execution are analyzed to determine the software performance and identify any defects or issues. So I'll use this as an instance. Or let me take this last one. Defect with, okay, no. So let me quickly give you this illustration. Say for instance, you which is something I've used before anyway. You make a food and okay, let me use this as an example, just on a lighter mood. So my youngest child, he kind of knows the taste of food a lot because I don't know, anything he likes, he knows the taste well. So he knows what is expected. So there was this day I made the jollof rice and it was salty. I'm not a bad cook. It was salty, and then I just thought, okay, it's something they can manage. So when I gave it to him and his siblings, the other one said, oh, it doesn't taste well. But then he said, it doesn't taste well as it should be. I think if I could remember the way he phrased it, he said it doesn't taste the same. So maybe because he's too young to tell me he's salty, but he kind of gets it that this thing doesn't taste right. So there are some people you will tell them, please test soup for me. They will come, they will test the soup. They'll say, I tasted it, but it didn't taste well. But they will not tell you what is missing. Why there are some people, they will come and taste the soup for you, and they will tell you, it's crayfish. You didn't put crayfish. If you put enough crayfish, this thing would have tasted better. Why some people will tell you, oh, you should have put more Maggi, or in this case called bouillon, it would have tasted better. So as a tester, that's where you go deep when you are testing. That's why they say we break things. People will say, what are you people always looking for? So when you are testing, ordinary person can come and look at the software and say, oh yeah, it's working. Yeah, the landing page, I can see the landing page. But there is something you are saying, it could be cosmetic defect. Maybe the fonts are not in the right place, or the right number that it should be, or it could be that the color that was used, it could be a minor thing, but you as a tester, you can see that it's not right. But somebody that is not a proper tester will just come and say, yes, this it looks good, it's okay. But you as a tester, you know that no, this is not what is expected. That is what you are being paid for. You must find a bug as a tester. You must find a defect. You should, in any project. Trust me, if you don't find a bug, then you are being paid for nothing. So you must find it. That's why we go well above. You have to go extra mile to make sure everything is working as it should as is expected. So you also have the defect retesting. Any defect that are identified during test executions are retested to ensure that they have been fixed correctly. We will also do a different session on defect. So I'll quickly touch on this defect retesting. So when a defect is being fixed, say for instance, after a tester have raised a bug and the developer then comes and fix it, sometimes when it's being fixed, you have to do regression testing. We call it regression testing, because the one that has been fixed can then affect another feature. So in that process, you have to test all this. And then even the defect that has been fixed, you have to retest it. Then we also have test reports. Test reports are documented and reported to the relevant stakeholder. Then you have the deliverables of test execution. Reports, let me just move this. Yeah, defect on any defects that have been raised during the test execution phase. Overall summary of test cases results. So time is fast spent. We're almost done. That will take. So the test closure report is the final stage of the software testing lifecycle, where all test-related activities are completed and documented. The main objective of the test closure stage is to ensure that all testing-related activities have been completed and the software is ready for release. Then the test closure report must contain test summary report. It must contain the defect tracking. It must also contain the test environment cleanup, the test closure report, and all that. The deliverable test matrix, test closure report is a document that gives the overall summary of the testing activities in a nutshell. There's more. So we then also have the SDLC versus the STLC. Let me move this down. So STLC is related to software testing, while SDLC is primarily concerned with software development. STLC, fewer people are involved, while in SDLC, more people are involved in all processes, a number of developers. In STLC as well, you ensure that anything we produce meets customer needs and that the products are of high quality, while in SDLC, you ensure that they are building the correct thing in the correct manner. Then STLC is a testing life cycle, while SDLC is a development life cycle. STLC is concerned with both of the development and testing process, but it's primarily concerned with the testing process, while software development life cycle ensures that we deliver high quality software, which as per client's need. In STLC, QA team analyzes all the requirements from the requirement document and creates a system test plan. In SDLC, business analysis gather all project and related requirements from a stakeholder and create a development plan. In the software testing lifecycle, the test architect or test manager creates a strategy to test a software application, while in software development lifecycle, the team creates the high level and the low level design of projects based on clients' requirements. So this is just a clear picture of what the SDLC and the STLC looks like. So for the SDLC, you do requirement analysis, while in that one, STLC, you do system testing. Once the entire website has been developed, system testing is performed to evaluate overall functionality and performance of application. Then for the high level, you also have the integration testing, which verifies that the individual software modules work together as a specific. It's focused on testing the integration between different components or systems to ensure proper integration communication, while the low-level design of the SDLC in unit testing, developers write unit tests to verify the functionality of individual components or modules. Then you have the coding as well. So the developers do write the unit test to ensure that the product's listing page, for example, display product correctly. So yeah. And that's it. Thank you. Any questions? So I will stop the recording and then.
Lovely one, lovely one.
Oh, thank you.
Thank you very much.
Thank you.